All right, guys. Thank you guys so much for your patience. We appreciate that as we figured this out. So this is the ham radio workshop presented by the IEEE UTD Technical Committee. My name's Connor Hamilton. Presented by the IEEE UTD Technical Committee. My name's Connor Hamilton. Shreya and Sarvan, do you guys want to go ahead and introduce yourselves?
Yeah, hi, my name is Sarvan Narayanan. I'm the Vice President of IEEE as well as helping out with the ham radio workshop here. I'm going to be in the chat or in the stream answering any questions you guys have, so feel free to comment and say hi or reach out and say any questions. Shreya, you want to introduce yourself? I think you're muted if you're trying to talk. Ah, okay. All right, so.
All right, guys, yeah. It looks like Shreya is going to try to figure out what's going on with her screen. For the meantime, you guys can go ahead and sign in using this link. Perfect. And we'll try to get Shreya back.
Okay, hi, I'm back. So there should be a QR code up, so if everyone could just take a moment to sign in, that'd be great. Okay, so we're gonna go ahead and get started. If you didn't get a chance to sign in, you can you'll get the chance later. So this workshop is brought to you by the IEEE UTD Technical Committee, which strives to help our members cultivate their technical and engineering skills through various workshops. So you can join the Discord to learn more about the technical committee, and you'll also be notified of any upcoming workshops that you can attend. Okay, so we're going to start off by just explaining what is ham radio. So ham radio is a popular hobby and service in which radio frequency spectrum is used for non-commercial message exchange, wireless training, radio sport, and more. So there are three classes of licenses that individuals can get: the technician, the general, and the amateur extra licenses. The technician class license is the entry-level license, which gives the individual the ability to access all amateur radio frequencies above 30 megahertz, and the ability to participate in local communication. The general class license allows for worldwide communication, and the amateur extra class license allows for individuals to use all bands in all modes. So how can you get licensed? So before COVID, exams were held in person by local radio leagues. Currently, online exams are being offered virtually.
All right, guys, so your first question right now is probably, why should I get my ham radio license, right? Why am I in this technical workshop? So the first thing that I would bring to your attention is, we go through these classes as EE and CE majors, and we learn all this theory, but when do we get that technical, hands-on knowledge? And so what ham radio or amateur radio allows is that, like I said, hands-on technical knowledge like a technician would get. And so as engineers, it's so important that we learn the theory, but also understanding the hands-on application of what we're doing is so helpful. So learning how, for instance, radio communication works and building radios, understanding circuitry of a radio is so important, so helpful for your career and getting a job in the future. You also learn principles for usage of radios and the ability to partake in different community events put on by radio clubs. So some of those things could be radio competitions, transmitter hunting. We'll talk about that a little bit later, but it really opens up a whole world of just fun, technical knowledge that you can use. So some of you also might be interested in becoming an RF engineer. And so early hands-on knowledge of principles of ham radio, getting your feet wet with some of the, like I said, just seeing what it's like day to day and working with, like I said, the theory of what you learn in class can help you understand, okay, maybe this is something I'm interested in. This is maybe a field I want to go into. And, kind of a topical thing, 5G is at its advent right now. And we can see all the major telecom companies are talking about it a lot. We see it in commercials. And so this is something that, because it's so topical, jobs are increasing, and we're seeing more and more people want, companies wanting engineers that understand, even that technical knowledge that we don't necessarily always get in school. So I'll go to the next slide. And, another thing that is pretty interesting about amateur radio is it continues to be operated in disaster situations. So one community specifically called ARES is the Amateur Radio Emergency Service. So if you think back to Hurricane Harvey, so I personally used to live in Houston for a number of years. And when Hurricane Harvey hit, and you guys probably remember, it devastated the entire southeast Texas. Well, amateur radio communities, especially like ARES, as I spoke about before, were vital in communicating between first responders and the victims of the disaster itself. And so they were able to help people seek shelter, help people to find supplies. And then more recently, I'm sure we all remember the February winter storm that we all went through when nobody had power. And a lot of people had to go to local stadiums and things like that just so that they could find shelter. Well, ARES and the Dallas specifically, the Dallas chapter was integral in putting people together with shelter, food, clothes, whatever they needed. And so this tangibility factor, I think as a future electrical engineer, I think that to me is so exciting. And I hope that, you guys, think, I'm not just becoming an engineer because it's interesting. It's a way to kind of give back to the world and make the world a better place. And so ham radio actually offers you the ability to do that. And so, in the next slide, the question becomes, what benefits do I get as an EE or a CE major? So we get knowledge of real world radio circuit designs. We learn how to troubleshoot and fix radios as they come. Figure out any problems that we might be having, and you learn all these things that, so in class we learn the theories, right? And then all of a sudden we're thrown into using, I'll use, PSpice as an example, use PSpice. And suddenly it's like, wait, why is my graph not showing? Or why is my simulation not running? So the ability to do that and then connect that to the theory of what you learn in class is an integral skill. The earliest an electrical engineering major learns about radio communication, if you take every class as early as you possibly can, would be your junior year. That's as early as you could possibly take RF circuit design. So getting your amateur radio license offers you the ability to kind of get your feet wet, like I'd mentioned before, and to learn about things as you go. So whenever you finally do get to that class, you already have an idea of, okay, this is something I'm already interested in, I know a little bit about, and I can bring the knowledge that I have previously into the knowledge that I want to learn more about. So there's a handful of classes that actually help out with learning amateur radio. ENA, you learn basic circuit design, you have passive elements, and you learn how to build different circuit topologies. Signals and systems, you're learning the basics of signals and transmission of waves. EMAG is the big one that everybody has to take. That's the one that most people are afraid of, and it's really never all that bad. And then RF circuit design. Like I said, these are the 4 classes that basically build the fundamental blocks of, I want to learn more about RF engineering. So learning about amateur radio, taking the test, getting licensed, and getting things wrong to learn more about it, I think is a really exciting way to use the theory that you learn in those 4 classes specifically. So in the next slide, if we move on, we can see how does getting an amateur radio license actually help me get a job. So I've pulled from 2 different job listings, one from an entry-level RF engineer and the second from a second-level RF engineer. So in the first job listing, we can see, okay, obviously they want you to have a bachelor's degree in EE. But the second and third bullet points bring up 2 good topics for us, especially learning about amateur radio. Number 1, experience working with or performing engineering studies of basic radio frequency communication systems. The third one is experience or familiarity with radio frequency devices or systems. These are both all about the things that you will learn whenever you take your test and get licensed for amateur radio. And it's concrete, right? Those are absolutely what you're doing. You could go into the job interview and say, I have 100% done this and I'm comfortable with it. We see the second job listing here, RF engineer 2. The bullet point says prior experience in telecommunication engineering activities. So that could be something like I said, our amateur radio license or IEEE microwave society. These are things that you're doing that are improving your knowledge of RF engineering, telecommunications, and like I said, learning more about the world of RF. So I'll pass it back to Shreya now to talk about how we get licensed.
Okay, so now we're going to talk about how you can get licensed. So before COVID, exams were held in person by local radio leagues. And now currently online exams are being offered where like a volunteer examiner team consisting of several members from a local amateur radio league will be supervising a test taker through like a video conferencing platform like Zoom. So the online exams are set up so that you'll be able to take the test on one device, where proctors will be monitoring your screen, and another device like your phone or tablet will be used to show you actually taking the exam. So to take the exam, you do need a US mailing address. This can be like a residential address or like a PO box, and a FRN or an FCC identification number. So if you do not have a social security number, then you will need to register for an FRN before the exam, which can be done through the FCC website. If you do have an SSN, your FRN will be issued after the exam. So specifically for the technician class license exam, which is the entry-level license, the test will consist of 36 multiple choice questions that will be pulled from a test bank that's already available to everyone on the ARRL website, which is the National Organization for Amateur Radios. So you will need to get 26 questions right, which is a 74% on the test. And the test itself takes 15 minutes long, but with the online exam format, it can take up to 45 minutes for the proctors to relay information and the rules. And it's recommended to study about 10 hours for this exam, though it might not take you 10 hours to study for it, and the cost of the exam is $15. If you want to get additional licenses, such as the general class license, you still have to first take the technician class license exam, then you can take the general class license exam. So you basically have to take the previous class exams before, but you can take on multiple exams within the same day. So now we're going to go over some different sample questions. So we're going to start off with some general information questions. So the first question is going to be, on which HF bands does the technician class operator have phone privileges? A, the 10 meter band only, B, 80 meter, 40 meter, 15 meter, and 10 meter bands, and C, 30 meter band only. So I'm going to give everyone about 15 seconds to think of an answer. Okay, so the answer is A, 10 meter band only. So HF stands for high frequency, and it refers to radio frequencies from 3 to 30 megahertz. So the technician class license, if you hold a technician class license, it's limited into use of the HF band. So with this class license, you have access to phone and data privileges on a portion of the 10 meter band. So if you want to work with the HF radio or a high frequency radio, you will need to get a general or an amateur extra class license. Okay, so we'll move on to the second general information question. Which amateur radio stations may make contact with an amateur radio station on the International Space Station, or ISS, using 2 meter and 70 centimeter band frequencies? A, only members of amateur radio clubs at NASA facilities. B, any amateur holding a technician or higher class license. C, only the astronauts' family members who are hams. Or D, contacts with the ISS are not permitted on amateur radio frequencies. So again, I'll give everyone 15 seconds. Okay, the answer is B, any amateur holding a technician or higher class license. So there are no special requirements for licensing to be able to talk to a satellite or a space station. So as long as you have access to transmit on the uplink frequency, which is the frequency that satellites listen in on, you can communicate with it. So anyone with a technician class license or higher can communicate on the 2 meter and the 70 centimeter bands. So the technician class operators can make contact with the space station on these band frequencies. So the last general information question is, which of the following is an acceptable language to use for a station identification when operating in a phone subband? A, any language recognized by the United Nations. B, any language recognized by the ITU. C, the English language. Or D, English, French, or Spanish. So I'll give everyone 15 seconds. The answer is C, the English language. So within the US, you can use any language that you wish to communicate over amateur radio. But when you're identifying your station with your call sign, you must use English. So next, we're going to go on to a calculation question.
Okay, perfect. So I'll start this one off. And the question reads, what is the approximate amount of change measured in decibels of a power decrease from 12 watts to 3 watts? So if anybody knows, they can type it in. Again, I'll give you about 15 seconds and then I'll kind of go over it. All right, so if you guys said minus 6 dB or C, you're correct. So if we go to the next slide, it shows us a little explanation of why. As a freshman or a sophomore, or even sometimes a junior, you might be a little confused as to what is a decibel, and I hear that word, but I don't actually know what it means. So decibels are relative units of measurement at a log scale. So basically, it's relative to whatever measurement you're taking. So I have two equations here that you can use. You can plug them into your calculator and you'll get the right answer 100% of the time. You have one in milliwatts and one in decibels, dBm rather. So you can do either of those, that's totally fine. And if we go back to the previous slide, you can see, okay, we start with 12 watts, we go down to 3 watts. So we would just actually divide those numbers together, 12 divided by 3, so that's 4. And then 10 log of 4 is 6. If we are going down in power, we're decreasing, so that would be a minus sign, so then it would be minus 6 dB. So another way to think about this, though, and it might be a little easier to think about it this way, for every wattage increase by 2 times or decrease by half, there's a change of plus or minus 3 dB. So let's go back to the question, or to the slide previous. So we're going from 12 watts to 3 watts, right? So 12 divided by 2 is 6, and then 6 divided by 2 is 3. So we've decreased by half twice. So 2 times 3 is 6. We're going down, so that's in the negative direction, so minus dB. So that'd be minus 6 dB. So I hope that was a good introduction into decibels and how they work, what they are, and kind of relieve a little bit of the mystery behind what decibels are, especially if you're earlier on in your studies. So I'll pass it back to Shreya to keep us going on the calculation questions.
Okay, so let's move on to the second calculation question. So it reads, what is the current in a circuit with an applied voltage of 120 volts and a resistance of 80 ohms? A, 9,600 amperes, B, 200 amperes, C, 0.667 amperes, or D, 1.5 amperes. So I'll give everyone 15 seconds. Okay, the answer is D, 1.5 amperes. So Ohm's law, the general Ohm's law equation, states that voltage in volts is equal to the product of the current in amperes and the resistance in ohms. So in this problem, you're given the voltage and the resistance, and you want to find the current. So you can just basically rearrange the Ohm's law equation, get that current is equal to the voltage divided by the resistance. So when you're plugging in the numbers, 120 volts divided by 80 ohms is equal to 1.5 amperes. Okay, so for the last calculation question, it reads, what is the formula for converting frequency to approximate wavelength in meters? A, wavelength in meters equals frequency in hertz multiplied by 300. B, wavelength in meters equals frequency in hertz divided by 300. C, wavelength in meters equals frequency in megahertz divided by 300. Or D, wavelength in meters equals 300 divided by frequency in megahertz. So I'll give everyone 15 minutes. 15 seconds, sorry. So in general, there's the formula for wavelength in meters multiplied by the frequency in hertz is equal to the speed of light, which is about 3 times 10 to the 8 meters per second. So if you kind of rearrange the equation, convert the frequency to megahertz, the equation can be changed so that wavelength in meters multiplied by the frequency in megahertz is equal to 300, which correlates to D, which is wavelength in meters equals 300 divided by frequency in megahertz if you, again, rearrange the equation. So it might just be easier just to memorize this final equation. So we're going to now go through 3 circuit diagram questions. So the first question is, in the circuit diagram to the right, what is component 3? A, a connector, B, a meter, C, a variable capacitor, or D, a variable inductor. So I'll give everyone 15 seconds. Okay, the answer is D, a variable inductor. So first, if you look at component 3, you can tell that it's an inductor because it looks like a little coil. And inductors are made of insulated wire wound into a coil. And then usually a diagonal arrow going through the component, like in components 2, show that it's a variable component. So component 3 would be a variable inductor. The next question is, in the circuit diagram to the right, what is component 3? A resistor, B, a transistor, C, a lamp, or D, a ground? I'll give everyone 15 seconds to answer. Okay, so the answer is C, a lamp. So this component is an incandescent lamp where the looping line inside of the border shape, it represents like the filament inside the lamp. So current would be able to flow through the circuit, causing the filament to glow and the lamp to emit light. Okay, so for the last question we're gonna go over today, it reads, what is component 8 in the figure to the right? A resistor, B, an inductor, C, a regulator IC, D, a light emitting diode. So again, I'll give everyone 15 seconds to answer. So the answer is D, a light emitting diode. So if you look at component 5, that is an example of a diode, which is represented by an arrow with a line against the tip. So a light emitting diode, like in component 8, is essentially a diode that emits light. And you can tell that it's specifically a light emitting diode because of the zigzag lines next to the component, which symbolizes that light is emanating from the diode. So those are all the sample questions I'm going to go over today. So I'm going to hand it back over to Connor.
Yeah, so one thing I wanted to mention, and I'll mention it before we get off the call again, is we'll be holding a second workshop and it'll be specifically going over these questions. So that's all it's going to be. We'll be just drilling questions all night long, and we will be able to review so that way you can be better prepared to take the exam. And that will be on April the 9th. That's when it's scheduled right now. So we'll send you a reminder on Discord and we'll be able to do that. Once you guys actually sign up for the test, take and pass it, we'll be able to provide more workshops in the future to follow this up. And there's so many fun so many fun workshops that we can provide you guys once you guys get licensed. So if we go to the next slide, one of the first ones would be radio receiver building workshop. So basically in technical committee, a lot of times what we do is we set up a technical workshop where you guys can use like Arduino, and you guys can use pretty basic components that you've learned in class, and you can create something. So this would be using an Arduino, some knobs, and an LED display, or LCD display rather, and we'd be able to create a radio. Pretty basic, but a lot of fun. And you know, you start with that and you can build off of that and kind of go wherever you want from there. And one of the more advanced workshops, if we go to the next slide, would actually be fox hunting. And so I had kind of talked about this before, where you split into teams, and we as the technical committee would put a transmitter somewhere on the UTD campus, and you would go hunting for it. And so you would build a makeshift antenna with your team. You would use the radio that you received and once you got your license, and you would go hunting for the radio. So there's rules, and you're trying to figure out, okay, how do I find this radio? If you want a kind of a visual of this, if you guys have ever played one of those games like Fallout, for instance, I know there's a part in a video game like that where you have to go hunting for these transmitters all over the little map. And basically that's what fox hunting is, right? You get closer, and I'm diminutizing it a little bit, but you get closer and it beeps quicker, and you know you're getting nearer to the transmitter. And so it's a lot of fun, it's competitive, and you're trying to build other components, competing with other teams. And so it's a lot of fun. So if we go to the next slide, you know, one thing I wanted to leave you guys with was just some resources. So one of the biggest resources is going to be arrl.org, like Shreya had mentioned before. This is going to be where you're going to be able to find question pools. You're going to be able to find resources like books. You're going to be able to find principles for radio, utilization of radio, like I had mentioned before earlier in the workshop. And so if you can start at that first link, but the links the two links below that are actually test pools. So, we went over 3 questions in the 3 different categories of questions, but there are over 400 questions in this technician test pool. You can peruse over them, you can look over and see, okay, where am I strong or where am I weak? If you're later on in your EE career, you're probably looking at those circuit diagrams and you're like, yeah, this is pretty simple. And it is. And the calculation questions also might be a little simple. But those general knowledge questions are the ones that can get you. They can be real specific and you may not know. And so utilizing those test pools is a huge benefit. Below that, I have included the Dallas races, and that is the local community here for disaster relief services. And so for me, like I said, that was a big thing that I wanted to leave you guys with. I think that as an engineer and becoming an engineer, one of our responsibilities is to try to make the world a better place. And I think that through amateur radio and here in Dallas, we have that opportunity. And I think it'd be a great thing to take advantage of that. And then finally, one of the resources that I used that was so helpful was hamstudy.org. It's got a bunch of question banks and practice quizzes and a bunch of things that will help you when you're studying for your exam. So going to the next slide, a little bit about technical committee. So technical committee meets Thursdays at 11:30 a.m. And we basically do this. We put on workshops for people like you who are anywhere from freshman to a senior, who just want to learn more about technical things relating to the major you're in. So personally, I actually got my business degree and then I went to work for a while and I decided later on I wanted to come back to school and get an engineering degree. To me, the biggest thing in my way was my lack of technical knowledge. I had almost zero. In fact, I had zero. I shouldn't say almost zero. I had zero. And technical committee was the place I could go where, there was no judgment. It was totally open for someone like me to ask maybe the dumbest questions anybody's ever asked before, but it was great because I got to ask these questions in an environment that was so welcoming and open to helping me learn at my own pace. And it was good for me. And then I'll use, other people as well who have more technical knowledge. They also benefited from it because there's so many people involved that at whatever level you find yourself, whether it's like me, very, very beginner, like I was when I started, or someone who begins very advanced in their career, maybe in junior high, you had experience in technical things at school when it comes to EE stuff. We provide resources and help to anybody in those levels. And so again, we meet Thursdays at 11:30. And if you're interested on the Teams chat, there's a place where if you go to the IEEE UTD Teams group, you can comment in and tell us you're interested. You can also reach out to us on Discord as well. So let's go to the next slide and we'll just do a little plug here. Comet Hack is going to be April the 23rd through the 25th. So I think that's about 4 weeks. It's a 36-hour challenge, hackathon for beginners all the way up to advanced. You get into groups of 1 to 3 and you have a project and it's a ton of fun. You get the chance to win some prizes. You can network with other people in the industry and it'll be a ton of fun. So you can actually register right now at comethack.org. And so follow us on the social media to learn more. And if you have any questions, like I said, feel free to reach out. Totally open for that as well. So does anybody have any questions? We can go to the final, the question slide. I'd love to, if you guys wanted to reach out and just ask anything about if it's ham radio or if it's technical committee, we are absolutely open to answering your questions.
All right, if we have no more questions, then thank y'all for coming to join us. And our next workshop is going to be this Sunday on at 7 p.m. with Nolan Davenport. He's going to be going over a continuation of Kwong's PCB workshop. So hopefully we can see y'all there and y'all can learn more about PCB. But thank y'all for coming tonight. Have a good night.